Welcome, everybody, to another fantastic edition of CMA Math Academy. So we're going to start this Math Academy off a little bit differently than we normally do. So as you guys know, both me, Mr. Grady, myself, and Mr. Schrog are expecting children in the future. So both of us are going to be dads coming up. So one trait about being a great dad is that you have to have awesome dad jokes. So if you don't know what dad jokes are, Urban Dictionary defines a dad joke as an embarrassingly cheesy or dumb joke made by a father to his children. So maybe you can think of your dad telling some dumb joke or cheesy joke that really is awesome, and you know it's funny, but you're just too cool to try and laugh. So since me and Mr. Schrog are both about to be dads, I figured we should start this off with some awesome dad jokes about each of your core subjects. So there's going to be one for every core subject that you have, right? So you know these are going to be funny. Try to control yourself. Let's talk about our first one. So the first joke comes from language arts. Why should you never date an apostrophe? This is a tough one. Why should you never date an apostrophe? Because they're too possessive. Oh, that's a good one. That is that's all. That might be my favorite one. I don't know. These are all great. Let's go to the next one. So we had language arts. Here's social studies. What do Alexander the Great and Winnie the Pooh have in common? What do they have in common? Alexander the Great and Winnie the Pooh have in common. This is tough. They have the same middle name. Oh my goodness, these are awesome. Winnie the Pooh, Alexander the Great, get it? Even the baby's laughing. This is fantastic. All right, now we're ready for science. So this is a fantastic one. How does NASA organize a party? They plan it. Get it? Plan it. Planets, the planets, NASA. Whew, these are just getting better and better. All right, and our last one, I saved the best for last because it's math. Ready? What should you do if you get cold during your math class? What should you do if you get cold during math class? Go stand in the corner. It's 90 degrees. Oh, man, those were good. Even the fox is laughing. Whew. All right, so now that that's over, let's go on to our objectives for today. So what are we going to learn? Why are we going to learn it? And how will you know if you successfully learned what you need to learn? So let's look. Today, you guys will be able to estimate the square root of a non-perfect square, so that's important, to the 10th place value, to the 10th place. So one decimal place over the 10th place. Why are we learning this concept? So if we can correctly estimate the value of a number, then we will be able to accurately place it on a number line. So our next step after today is to place our number on a number line once we've estimated it. So that's where we're looking forward to. And then how will you know if you've successfully learned it? So when given a non-perfect square root, if you can correctly estimate its value to the 10th place, so one decimal place over, then you will have been successful for what you need to do for today. Okay, so let's go ahead and get started. So you have this paper in front of you. If not, I'm going to let Mr. Schrog and myself pass it out for a second. But otherwise, you have this in front of you. Go ahead and put your name on it. And let's walk through what we have here. So before we can estimate square roots that are non-perfect, we need to discuss perfect square roots. So looking at this sentence, it says, a perfect square root is when the answer to a blank is a blank. Okay, a perfect square root is when the answer to a square root is a whole number. So we discussed this a little bit last week in our Cornell notes, that if we have a square root and the answer is a whole number, that's called a perfect square. Everybody say perfect square. Before we look at estimating square roots, we need to look at some perfect square roots. So we're going to fill this chart in with the first 12 perfect square roots. Now, obviously, there are more perfect square roots after 12, but these first 12 are the ones we need to get memorized and store them away and know these perfect square roots. Okay, so we're going to fill in the first 2 together, and then you're going to do the rest of the chart on your own, and then we'll come back and check our work. So the first perfect square root is the square root of 1. So we know it's perfect because the square root of 1 is 1. And again, that's because 1 times 1 is 1. Remember, when we have a square root, it's something times itself to get this number in here. So the first one is square root of 1 because that's 1 times 1. Our next perfect square root is 4. And again, it's a perfect square root because 2 times 2 gives us 4. So the square root of 4 is 2. It's a whole number. So now I'm going to let you guys have some work time, and you're going to go down to the next line and do 3 times 3. See what that one would be. 4 times 4, 5 times 5, and go all the way till you filled in all the way over here to the bottom of our right column. So I'm going to give you a minute to fill in all the perfect square roots. Go. All right, so now that you've had a chance to work, I want you to take a second, just check your answers real fast. I'm going to give you about 15 seconds. Check your work with your table partner before we move on. Make sure we have all of these correct. Go. Okay, so let's check our work. So here are all of the perfect square roots. So we know the square root of 9 is 3. That's a perfect square root. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Then over to the right, square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And the square root of 144 is 12. So these are all of our perfect square roots. Now again, we're going to use these perfect square roots to estimate non-perfect square roots. So since it's not perfect, you could probably guess our answer will not be a whole number. We're going to have a decimal, and as we said in our objective, we're going to round that decimal to the 10th place, so 1 decimal place over. So I want you to look at the next part of your notes here, and we have some blanks that we're going to fill in our steps as we work to find out what the square root of 50 is close to. So we're going to estimate about what the square root of 50 is close to. So the first blank over here says, determine the blank, 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 and blank the square root you are estimating. So as we go through this, here's what you're writing. So this is going to say, determine the perfect square. So I'm going to write this, perfect square. Determine the perfect square before and after the square root you are estimating. One more time. Determine the perfect square before and after the square root you are estimating. So here's how we're going to show this over to the side. So we have the square root of 50 we're trying to estimate. So the first thing we're going to do is we're going to make 2 arrows. 1 arrow to the left side and 1 arrow to the right side. And this is just to organize our information. So we need to figure out the perfect square before 50 and after 50. So to do that, we're actually going to look back at what we have up above on your paper or the previous screen for me. So here's what we had before and what you have up above. Remember, we're trying to find the square root of 50. So we're looking through our perfect squares and trying to figure out where 50 would be in between. So as we go through this, I know 50 is way bigger than 16, bigger than 25, bigger than 36. But I get over here and I realize, okay, the square root of 50 would fall in between the square root of 49 and the square root of 64, because 50 is in between 49 and 64. So I'm going to use the square root of 49 and the square root of 64 to work this out. So to the left, I'm going to write down the square root of 49, because I know that was what was before 50. And then after 50, the next square root was the square root of 64. So I have the square root of 49 and the square root of 64. 50 came between those. Okay, let's look at our second step. The second step says, find the blank blank of each perfect square. So what this is saying is you're going to find the square root find the square root of each perfect square. So let's do that. Well, I know that the square root of 49 is 7, because remember, 7 times 7 gives me 49. So I'm going to draw another arrow, and I'm going to put a 7. So I know the square root of 49 is 7. I also know that the square root of 64 is 8. So I'm going to put that. I'm going to come over here, and I'm going to put an 8 on this side. So now we've done the second step. Find the square root of each perfect square. Number 3 says, determine which blank blank your blank should be closer to. So for us, our blanks are going to look like this. Determine which square root your estimate should be closer to. So let's think about this. If I look over to the right side, I'm trying to decide, is 50 closer to 49 or 64? And that's going to tell me which number, 7 or 8, our answer, our estimate, should be closer to. Well, I know that 50 is only 1 number away from 49, but I see that 50 is 14 numbers away from 64. So my answer to number 3, determining which square root it should be closer to, that tells us that it's going to be closer to 7 than it is to 8. So we're just going to know this, and we're going to put a little arrow going down kind of towards the 7. So I know 50 is actually closer to 7 than it is going to be to 8. So there's our third step. So the fourth step, calculate the square of the halfway point. Okay, so let's think about this. I'm trying to figure out what's halfway between 7 and 8. I'm trying to figure out what would be the halfway point between 7 and 8. Well, I know in decimal form that the halfway point is 7 5/10. So there's my halfway point. I need to square that number. Now, you'll notice we've taken away your calculators today. We don't want you to use your calculator on this. We want you to do all of this by hand. So I left room over to the side, and I'm going to multiply 7 5/10 times 7 5/10, because that's what it means to square a number, multiply it by itself. So I'm going to go ahead and do this. Now I want to give you a second to multiply this out on your own, and then we'll come back and check our work. Go. All right, so let's see how we did. So I have to start on my right side with this 5 at the bottom. So I'm going to do 5 times 5, which I know is 25, and 5 times 7, which is 35, plus 2 is 37. Okay? From there, I move over to my 7. 7 times 5 is 35. Now, before I write this down below, I need a placeholder, so I put a 0 there. So I have 35, carry the 3, so I'm done with that too. And I have 7 times 7, which is 49, plus 3, which is 52. So then I'm left with adding. So I just add this up. 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1. 1 plus 3 plus 2 gives me 6. And I'm left with a really big number. It looks like 5,625. However, remember, when I multiply two decimals, however many place values are behind my decimal, so in this case I have 2, the 5 at the top and the 5 at the bottom, that's how many places I move my decimal over. So my decimal point is actually between the 6 and the 2. So I realize that 7 5/10 squared gives me 56 25/100. So if I want to come back over here, underneath where I already wrote 7 5/10, I'm just going to write that number out, 56 25/100. Now you might be saying, how is this all going to help us estimate our square root? Well, if we think about it, we've already decided that 50 is closer to 49. If I use 7 5/10, that puts me basically at 56, and 56 is not very close to 50. So that tells me when I estimate this square root, I want it close to 7, and I really don't even want it close to 7 5/10, because 7 5/10 is obviously way too big. So if we move over to step 5, our fifth step is to actually estimate. So we're going to estimate or take our first guess. Now remember what we were just saying. So we were saying that 50 is closer to 49, so our estimate has to be closer to 7 than it is to 8. We said that the halfway point, 7 5/10, is 56 basically, which is way above 50. So when we make our first guess or our first estimate, we want it to be really close to 7. So a guess that I'm going to take is 7 1/10. So I'm going to come down below, and I'm going to say that my estimate is 7 1/10. So now we go over to step 6, which says multiply to check your answer. So we're going to multiply just like what we did with 7 5/10 to see if 7 1/10 is a good estimate. So I'm going to come over here, and I'm going to add another 7 1/10, and I'm going to multiply those two decimals. So I'm going to give you a second. Go ahead and multiply 7 1/10 times 7 1/10. Okay, so let's go through and let's check our work. So again, when we multiply decimals, we start on the right. So we do 1 times 1. So 1 times 1 is 1. And then 1 times 7, which is 7. Remember, as we move over to our next decimal, you have to have a placeholder. So we put our 0 there. 7 times 1 is 7. And 7 times 7 gives us 49. Then our last step is to add this up. So we know 1 plus 0 is 1. 7 plus 7 is 14. So we have to carry the 1. 1 plus 9 is 10, and we have to carry that 1, and 1 plus 4 is 5. Remember, we move our decimal 2 places because we are multiplying numbers that had 2 digits behind the decimal. So we're going to move it 2 places over, and that leaves us with an answer of 50 and 41 hundredths. So if we think about this, our goal was to see if we could get as close to 50 as possible when we multiplied. So yes or no, is 50 and 41 hundredths close to 50? Well, hopefully you said yes. So since it is very close, that tells us that 7 1/10 is a reasonable estimate for the square root of 50. So over to the side, we're just going to have our answer written out, 7 1/10, circle it, and there's our answer. So we're going to do one more together, and then you're going to have some time to practice on your own. So let's look at the next one. So the next one on your paper is the square root of 34. We have our steps already filled in from when we did that on the previous question. So remember, our first step says to determine the perfect square before and after the square root we are estimating. So we're estimating the square root of 34. So if I go back up here to my chart, the square root of 34. So I'm trying to find where the square root of 34 would be in between. So as we go down, we see that 34 is in between 25 and 36. Square root of 34 would fall right in between those. So that tells me the two perfect squares that I'm going to use. So to the left, I draw an arrow, and to the right, I draw an arrow just to organize our information. We already said that the square root of 25 is the square root that's before 34, and the square root of 36 is the perfect square that comes after 34. So we're done with our first step. Let's go to our second step. So the second step reads, find the square root of each perfect square. So we need to find the square root. So the square root of 25. So you guys tell me on 3, what's the square root of 25? Ready? 1, 2, 3. And we should have said 5. So we're going to drop that down below. And we have 5. And then on 3, you're going to tell me the square root of 36. Ready? 1, 2, 3. And we should have said 6. So the square root of 36 is 6. So now we are done with our second step. Okay, so now we're ready for step 3. Determine which square root your estimate should be closer to. So if we look, we have 34, and we have to decide if 34 is closer to 25 or if 34 is closer to 36. Well, we know that 34 is 9 numbers away from 25, but 34 is only 2 numbers away from 36. So that tells us the square root of 34 has to be really close to 6. So let's go to our next point. So number 4 says, calculate the square of the halfway point. Now remember, we talked about this in our previous question. The halfway point is what is halfway between 5 and 6. So hopefully we know that halfway between 5 and 6 is 5 and 5/10. So we have to calculate the square of 5 and 5/10. So that tells us 5 and 5/10 times 5 and 5/10. So I'm going to give you a second here. I want you to go ahead and multiply this out and get your answer for what 5 and 5/10 times 5 and 5/10 is. All right, so let's see how we did. Our answer should have been 30 and 25 hundredths. So 5 and 5/10 squared is 30 and 25 hundredths. So we bring that back over just so we can have it here to use, and we write 30 and 25 hundredths back into our problem. So now we are done with step 4. Let's look at step 5. Step 5 is where we finally make our estimate. So 5 is estimate what we think the square root could be. Now remember, we're going to use all this information to help us. We've already decided that the square root of 34 should be closer to 6 than it is to 5. We already know that. We also know that if we look at the halfway point, 5 and 5/10, that left us at 30. So 30 is still not quite enough, and it's not really all that close to 34. So we say, okay, halfway is 30. The whole way is 36. 34 is still closer to 36, so our estimate needs to be closer to 6 than it is to 5 and 5/10 even. So let's go ahead and let's make an estimate. Now remember, our estimate can't say 6 and something because 6 is the maximum. So it has to start with 5. It has to start with the number that we already had. So we need to estimate something like 5 and 7/10 or 5 and 8/10. Now either one of those is probably going to be pretty close, but I want you to choose. So right now you're either going to do 5 and 7/10. So I'm going to write this up at the top. 5 and 7/10 times 5 and 7/10. Or you can do 5 and 8/10 times 5 and 8/10. So choose which one you want to use, and then we'll check which one is actually the best option here in a second. So either do 5 and 7/10 or 5 and 8/10. Go. All right, so let's check our work. So if you were somebody who chose 5 and 7/10, you should have ended up with 32 and 49 hundredths, which is still pretty close to 34, but hopefully we can get even closer. If you are somebody that chose 5 and 8 tenths, then you should have ended up with 33 and 64 hundredths. So again, both of those estimates are good estimates, but we hopefully see that 5 and 8 tenths is the better estimate. So that tells us that our answer isn't 33 and 64 hundredths, but our answer is 5 and 8 tenths. So down below, we're going to write our answer as 5 and 8 tenths. So we know that the square root of 34 is very, very, very close to 5 and 8 tenths. Okay, so now you're going to have some time to work. So there's one more question on the front side of this page. So you have the square root of 18 that you're going to calculate. So I'm going to give you just a minute. I want you to work with your table partner and calculate the square root of 18, and then you'll move on and we'll do the back here in just a second. Okay, square root of 18, go. All right, so let's check our work. So we should have seen that the square root of 18 falls in between the square root of 16 and the square root of 25. Your next step was to find the square root of each of those perfect squares. So we know that the square root of 16 is 4, because 4 times 4 is 16. And we know the square root of 25 is 5, because 5 times 5 gives us 25. We then can decide that our square root that we're going to estimate should be closer to 16, and again, that's because 18 is closer to 16 than it is 25, which means when we guess, our guess needs to be closer to 4 than it is to 5. So our next step told us to calculate the square of the halfway point, and I know that halfway between 4 and 5 is 4 and 5 tenths, so over to the side I did 4 and 5 tenths times 4 and 5 tenths, and that gave me 20 and 25 hundredths. So before I get to step 5 of estimating, I can kind of use this information. So I know 18 is closer to 16, so I need it closer to 4 than 5. Then I can also use our halfway point, which is 20 and 25 hundredths. And again, 18 is almost halfway in between 16 and 20 and 25 hundredths. So we can use this information to make a really accurate estimate. So we know if we want about halfway in between 4 and 4 and 5 tenths, then I would probably use 4 and 2 tenths or 4 and 3 tenths. So again, it kind of depends on which one you went with, but let's check both of those. So if you are somebody who went with 4 and 2 tenths, that left you with 17 and 64 hundredths, which is very, very, very close to 18. If you did 4 and 3 tenths, that left you with 18 and 49 hundredths, which again is also very, very, very close to 18. So how do we know which one is better? Well, when we're checking to see which one is actually our best estimate, we want to go ahead and see how far is our number away from 18. So if I think about this, 17 and 64 hundredths is 36 numbers away from 18. So this top number with 4 and 2 tenths is 36 numbers away. If I look at 4 and 3 tenths, 18 and 49 hundredths is 49 numbers away from 18. So even though both of these are very close, our actual best estimate would be 4 and 2 tenths, which is only 36 numbers away from 18. So our final answer over here we're going to write is 4 and 2 tenths. So again, we're saying that the square root of 18 is very close to 4 and 2 tenths. Okay, so you're going to have some time to work now. So there are a couple of things that you guys are going to do. First of all, you have 3 questions that ask you just to estimate the square root, like what we've been doing. So you're going to follow our steps from the front side of the paper to find these 3 square roots. After that, you have a little bit of a word problem. I have given you an example where David was asked to estimate the square root of 105. He has given you his estimate, but you're going to check and see if his estimate is actually the best estimate we could get. If a better estimate is possible, you're going to give a new estimate and explain why your estimate is actually better than David's. So you have some workspace that you can use to do your multiplication and to check your work and to work this out and see if there is a better estimate. And then down below, you're going to have a written explanation of why your estimate might be better than his if you found one that was better. Okay, so you have the rest of the time. We're going to work on the back. Good job today, guys.